Hi everyone and welcome back to CloudNets, where networks meet cloud. And today we're going to talk about optics. Yes, optics. No, don't go away. I know you hate optics and we'll talk about it in a different video, but today we're going to talk about the optics that goes into your router. We're going to talk about ZR and ZR Plus and OpenXR and stuff like that. And for that we have the expert for optics and everything that goes into a router, Ran. Hi Ran.
Hello.
Okay, so ZR and the family, other than being an evolution of ERLR, the best range, what are we talking about? We're talking about putting optics into the router, DWDM in the router? What's going on? What do we need to know?
Essentially,
how many things do we need to know?
Three.
Okay.
Three things.
Okay.
Yeah, that's the new three. Three things. The ZR optics brings location, and location to the game. No,
huh?
that's a different. Okay. That's a different video.
Okay.
Sorry, that's a different video. Okay. It brings in a longer reach. A distance that you can push the optics outbounds is longer with ZR than previous technologies. Talking about roughly 100 kilometers, give or take, and that depends on certain variables. The bandwidth can also change accordingly, and the distance can kind of expand according to that. So that's a longer reach. The second is the fact that it's leaner. There is one equipment that can be excluded from the network, which currently exists. That's a DWDM device that is connected to the router. So by plugging in the ZR optic, getting this kind of range into the existing router, you can actually dismiss one device altogether.
So instead of having the optics coming out from the router into a terminal multiplexer, putting it on a lambda and pushing it in a DWDM system, we have everything in a router, so we don't need an external box.
All that built into that transceiver. The third item, and that's perhaps the most interesting when it comes to ZR, is the fact that it's an open standard.
So lockout.
Yeah, locking out, the opposite of lock-in, right? It's the opposite of lock-in. Typically when you have a transport mechanism, an optical transport mechanism, then you will have optic coming from one vendor on one side of the line and the same vendor on the other side, because there is some proprietary coding to the line. ZR came and kind of standardized on this, so you can put a plug from vendor A and another plug from vendor B on the other side, and that will work. That's a very big thing.
And freedom for all.
And freedom for all. But that's not all of it, because ZR breaks down to three different form factors. It's DD, QSFP, it's OSFP, and it's OpenXR. And these three form factors, all of them are coming from various vendors, and all of them are being implemented. It plays an active role into the actual device, the physical machine that you're plugging the optics into it. And when it comes to a standard router, you need to kind of pick and choose, and some vendors are promoting different technologies. When it comes to our network cloud solution, which is essentially open, then you can have one ODM building with an OSFP and another one building with DD QSFP and another building with OpenXR, and they're all valid and they can all coexist in that same solution.
Wow, that's great.
That's big.
Okay, so this is what you need to know about optics coming into your router, the three L's, which are not location, location, location. You need to think about the longer reach you get, about the leaner infrastructure you have, because you eliminate the need for an external DWDM optical device outside your router. And you need to talk about the lockout, or the non-lock-in, non-proprietary open system that allows you to pick and choose different vendors for your infrastructure, different vendors, different form factors, different everything.
Correct.
So thank you very much, Ron, for explaining.
Pleasure.
Thank you for watching. See you next time on CloudNets.
Yeah.
Bye-bye.